Hello, how are you? Today, I want to do another major topic in C++ that you also saw in Python, at least most of you, but in C++, it's got many more possibilities than it does in Python. The concept I want to look at is the concept of a function. Now, there are built-in functions. We have used built-in functions as examples. We've used square root, and square root gets a number, like 36, or it gets square root of b times b minus 4 times a times c. Square root, we know square root is a function because it has those two parentheses. The open and close paren after a name means that we have a function with that name. Now, this happens to be a function that takes one thing inside. In square root, we have one value inside, well, one, I'll call it an arithmetic expression, inside the parentheses. That's the rule. Now let's look at a second example we did. So this is example 1. We've also had as an example, just recently I might add, ran. Now, ran is also a function because it has those two parentheses, but ran, the function ran, gets no values inside the parentheses. So each time we have a function, we have a certain number of things that it needs. And those are what go inside the parentheses. We'll have a fancy name for them in a minute. I want to give you another function or two that we had, other examples. We had set W, say 5. We had set precision, 3. We've had a few of these, and they're all functions that have already been written for us. A function is a complete program which does something that we want to we want to execute from another program. Technically, even main is a function, because you remember it gets to 2 parentheses at the end of it. Main is a function to C++, but to us it's the main routine. So what we call the values inside the parentheses the arguments of the function. What we're passing in, we say that we pass in these arguments. Now, sometimes we can also call them the parameters. I'm being loose on this. I think technically the parameters are the names that are used in there in the function, and the arguments are what we pass in, the values we want to send in. But we can live with this. So every function is essentially a built-in canned operation. You might think of it as having a very well-trained dog. The dog is very good. It can compute the square root. If you give it 36, it wolfs back 6 to you. It's a way that you don't have to know all the details involved in getting that 6 from 36. The same point with the set W. I don't need to know how the machine makes sure that there's 5 spaces, that the next variable is 5 characters. It's complicated. I don't want to know. But the machine, the program set W, the function, knows how to do it. The same thing with RAM. I know roughly that to do a pseudo-random number, we take 2 values, we multiply them together, and we take a certain portion of them. But I don't want to know the details. I don't want to know where I get those numbers or how I store them for the next time through or anything like that. I just want to get a number. So I let the machine bring back the number to me. Functions have many purposes. Functions make programming easier by hiding the details in another part of the program. Much of what we're going to do this semester and in the next semester is talking about encapsulating, trying to think in higher levels. I'd rather think in the level of square root than think of all the details I have to go through to get the square root. I haven't taken a square root since high school. I doubt if most of you have. I remember some very strange 2-column or 3-column way of doing it. I doubt if they still teach it. But I don't want to know that. I just want to be able to have that done. Well, it's the same way with many other things. It's better if we can delay them, push them off, even if we're writing them. That way we can think of the whole algorithm at once and then put the details in later. Now, there's another possibility here. We can reuse functions with different arguments that we send in. So once we write the function, we have it forever, or at least for as long as we have it in our program. So if I compute the circumference of a circle, and I want to do it for a circle of radius 5, and later a circle of radius 12, I don't have to rewrite it. It's already there. All I have to do is give it a 5 or a 12 and tell it to go to work and give me back the answer. So this streamlines frequently done things we need to do over and over, perhaps. There's yet another reason. Functions allow us to work in groups easier. More easily, that's the right way to put it. What I mean is that if you have a very complicated program and you have 3 people working on it, you can designate one person's going to write these functions, one person's going to write those functions, the third person's going to write a different set of functions, and the main program is going to call those and put them together to get the result. That way, it's a much better way of dividing up the work. And believe me, today, most programs that are really top of the notch take a lot, are big. When you get into industry, they're big programs. Sometimes one person just can't write the whole thing. I've heard that some operating systems, if you put one person on it, it'd take 100 years. They say it has 100 man years of writing it, although these days we would say 100 person years in writing the code. So you have to have teams, and functions make teams easier. Any language, practically speaking, provides some method for functions. Python provides one. The word you used was def, D-E-F, and you defined a function, and you even could pass arguments in it, and you could get values back from it. But you didn't have much choice how you did these things. In C++, like so many other high-level languages, there are many options. And we're going to look at some of them today and some of them in the next video. For an example, I'm going to try something that I don't, it's used a lot in probability and statistics, and therefore often in computing odds and games and things like that. So what I'm going to do is I'm going to begin by writing a function to compute the factorial of an integer greater than or equal to 0. Now I have to be careful. The computer does not have very good precision. Once I get past, I think it's 10 or 11 digits, I'm not going to be able to do this. And that happens pretty early. I will not be able to produce 13 factorial. I checked it out a few minutes ago. It's too big to put in, even for our machine. That's too bad, but that would just mean that you would have to find a fancier way to get bigger numbers. In fact, one of my projects last year in CFC 225, last semester, was to write a program to be able to add much larger numbers. So, what are we doing here? we know the definition. Factorial of 0 is 1. Factorial of n equals n times the factorial of n minus 1. Now that looks like a nice, easy way to do things, but unfortunately that definition is what we call a recursive definition. And we're not going to do recursion for a couple more weeks anyway. So we're not going to write it quite that way. Instead, what we're going to do is we're going to do it the following way. The form of a function is, first of all, a heading, then the body of the function. That's really not too much different than what you saw in Python. The heading can be, I'm saying can, I'll say is, because it's true, is the type of the function, the name of the function, and a list of the arguments separated by commas. It's worse than that, though. It's a list of the arguments and their types separated by commas. Once more, as I've said several times, this is a highly typed language. Everything has to be typed. So as an example, we're going to write int fact int n. That means that factorial will get one parameter, and that one parameter will be an integer. The first int says that this particular function will give us back an integer. So this is the heading, and it means, first, there is one parameter, and it must be an integer. Second, the function will compute an answer of type int and return it to the to the program that called it, asked it to work, however you want to put it. So headings have to be there. Now, as you might expect, that's very similar to what we had with int main, with the parentheses. So usually the heading will have int fact int n, and then the body is a complete program. And complete programs have whatever we want in them, and the braces holding it together, just as we do for the main program. Now the next thing, and this too should have been covered in Python, but if it hasn't been, we'll cover it right now. A function of type int double char string returns a value using the statement ent return some expression. That is the full statement, so it gets the semicolon at the end of it, separating it from any others. There has to be at least one somewhere in the body. And technically, every way out, every way the program could finish has to have one of those returns in it. Notice I did not say every function has to have a return. I said functions of these types have a return. And that's an important distinction. We're going to see that some functions don't want to return anything. They don't see any reason to. So we'll look at that in a minute. Now, let's go now over to C++ and do this in the less abstract and more we'll run the program method. So what I'm going to do, I'm going to create a new program, new project. Well, I hope I'm going to create a new project, yeah. And I'm going to call it, let's see, good fact. No, I'll just call it fact. Fact. Func. I'm trying to be careful because I already have a factorial program there from previous times. So, what am I going to do? Well, again, I want my using namespace standard to make it a little easier. Get rid of that. And I'll get rid of this. And now what I'm going to do is I'm going to go in here and I'm going to read an integer. So int n cout input integer between 0 and I'm going to take a chance with 12. I think 12 will work. And I'm not going to check it. I'm just going to let them, I'm just going to hope they do something that it's correct. Cin n. Now I'd like to print out the factorial of n. Now watch this. Cout fact n end out. I think I want to make it look a little bit better. I'm in the wrong mode. I've got to turn off the replace mode. I can't remember how I got into it, but I got into it. I think if I do this, it might turn it off. Now I can live with it. The factorial of n is factorial n indel there return 0. And my main program is written. It's done. So if I have somebody else who could write fact for me, I wouldn't have to do anything else. But I have to write fact too. So I'm going to go, the traditional way of doing this is the following. After the main routine, I write the fact. Now I can use any name here I prefer. I'm going to make it a different name so that you can see that. So I'm going to say int factorial of x. And then my program is going to be simple. I'm going to say int answer equals 1. If the x is 0 or the x is 1, then simply return answer. Else. Now I have to do the work. Basically, I have to multiply by 2, 3, 4, 5, 6, up to whatever x is. So for int I equals 2, I less than or equal to x, I plus plus, that's counting from 2 to x, including the 2 and including the x. I want to make answer equal answer times I. So if x is 2, this will do it once. It'll come in and do it. If x is 10, it'll do it for 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I think I got the close in that already. Yes, I did. So I don't have to do it myself. Now, I haven't returned the answer. I got to do that. So I return ans. There may be some of you who are wondering why. I wish I could remember how to get that to change. Oh, there it is. Now I have it. Return ans. Pardon me. There may be some who wonder why I didn't use the word fact here and here and here and here and here. Now the reason is that if I did, I'd be in the land of recursion. Until you know how to handle it, don't use the name of the function as a variable within the function. It's like handing dynamite to you if I say go ahead and try that, because it can be quite difficult. And I don't want you to try it until we've had a chance to play with it. So everything looks fine. I've got the program, and the program is here. But there's a nuisance problem. C++ expects that it will have a list of its programs that it's going to functions before it uses them. So let me go back down here. C++ must know what programs, what functions it will use before it uses one. Uses the function, let's say. But most people find that it's much better to put the functions after the main line. So how do we get around this? See, right now, if I run this program and I compile it, I'm going to get an error. And that error is going to say, fact is an identifier not found. So to fix that, I put a prototype of the function before the main routine. The prototype looks just like the heading. The prototype can be a copy of the heading. That's the easiest way to do it. There's technically, you don't have to have everything in it the same way, but I've always found it much easier. And it gets a semicolon at the end of it, because technically, I guess the prototype is a statement. All you do is take this part and you copy it right up here before the setup, but you have to put a semicolon after it. Now, once you do that, everything is fine. So let's see. Now put in 5. 5 times 4 is 20, times 3 is 60, times 2 is 120. 120. I'll put in 10, which I don't know if it's going to work. Yeah, that's not too bad. Let's see if 11 works. That's not too bad. Let's see if 12 works. That works okay. Now let's try 13. That's not the right answer according to Excel. I looked at my Excel, and my Excel says that I'm having so much trouble with this machine not responding properly. All right, there it is. Excel says that this that I'm looking at right here, okay, I gotta hit an enter. I think that'll take care of it. This is 13 factorial. We didn't get that. And that's because it's just too big. So there's the first of our programs. It's a function. It works nicely, does what we want. I'm going to copy it. I'm going to put it back into this handout that I will be sending to you. And let's see, go there. And I think I'll get rid of this top part. And then I'll go to a new page with it. So there we are, the first program. Now, that's not enough. If we have, say, 6 items, and we want to know how many ways we can put them together, then that number is called the permutation, and n factorial works at it. So, for example, if we have 3 people, June, Alma, and Clyde, we can arrange them in different orders. So, for example, we can say June, and then Alma, and then Clyde. Or we can say June, and then Clyde, and Alma. Or we can put Alma first, and then put June, and then put Clyde. Or we could put Alma still first, but put Clyde second. And then June. And why don't we try putting Clyde first? And then have June and Alma. And then we could have Clyde and Alma and June. Now, if you look at this, there are 6 ways, 6 different orderings, and it happens that 6 equals 3 factorial. And that's not an accident, because I can pick anybody for the first place. So I can pick June, Alma, or Clyde. Once I pick the first person, I have 2 choices for the second person. So I have 3, and I have 2 left over. And once I get those 2 in, I have no choice for the third person. So I have 3 times 2. If I had 4 people, I would have 24 different ways of doing it. Because I can pick any one of the 4 for the first place. I can pick any one of the 3 for the next place, that's 12. And then I can pick any one of the remaining 2, and that's 24. And then the last one's set. So that's called a permutation. This is all the orderings of 3 items. These are the permutations of 3 items. And there are some places where you would use it. That's permutations. If the order is important, for example, if you're having the batting order for your baseball team, and you had 9 people you had to put up in the batting order, well, you have 9 factorial ways you can put them together. That's quite a lot. Of course, usually you wouldn't try some of them, but you have 9 different ways of doing it. So it's it's something that's used quite frequently. Now, however, we might be interested in some other things. For example, we might be interested in how many 5-card poker hands we could have. Suppose we want to know how many different 5-card poker hands there are. Now, I don't gamble. I don't like, if I play cards, if anybody asks if we want to play for money, I'll say, fine, let's go for 1/1000th of a cent for each point. I don't particularly care to risk money on that. But the thing is that they're fun to play with. They're fun to write programs about. So let's see. We want 5 cards. The deck of cards has 52 different values. So let's see what we could do. We can take any one of the 52 as the first card. Then any one of the 51 left. Then any one of the 50 left. Then any one of the 49 left, and then any one of the 48 left. Now we do that, that means we have 52 times 51 times 50 times 49 times 48 ways of picking these 5 cards. Picking 5 cards, pardon me. Well, that looks a little bit like what I was doing above, but where's the 47 down? It's gone. So it's only the top part. Now this is purely intuitive if you think about it. It's not high mathematics. Just think of it rationally. Don't worry about the mathematics at the moment. Just say, okay, I got a deck of cards there. I can pick any one out. There's my first card. Now I got 51 of them left. I'll pull one out. There's my second card. And so on and so on. So you're going to have 5 cards over there. However, there's a problem. We might have the king first, then a queen, then a 10, then a 7, then a 6, all of spades, let's say. Or we might have picked queen first, then 7, then 6, then K, then 10. These would be the same hand. These 2 hands are not different. Well, how do we fix this? Well, we now go to what I was talking about with permutations. We have 5 cards. So if I give you those 5 cards, I could have picked them in 5 factorial ways. I could have picked any one of the 5 cards first, then any one of the remaining 4 cards second, then every one of the remaining 3 cards third, and so on and so on. So there are 5 factorial ways that I could have gotten this hand. So if I want different hands, then I can't take what I have up there. If I want different hands, then, now let's see, for every one of these hands that I have to get it down to 1. Then we have the 52 times 51 times 50 times 49 times 48 different hands that we could have. Those are the different sets of cards. We get that many different sets of cards. We don't care about the order. If we divide it by 5 factorial, then then we have different hands, because we are counting each one of the hands, the set of 5, only once. We're saying, yeah, those are the 5 cards you picked. I don't care what order you picked them in, but I'm only counting it once. I'm not counting the 5 factorial different ways you could have picked it. So that looks like a reasonable way. We call this the combination of 52 things taken 5 at a time. And this is written, we write this as C52, comma 5. Now, there's another way of looking at it. The traditional way of talking about it is to say, this is 52 factorial divided by 5 factorial times 52 minus 5 factorial. 52 minus 5 is 47 factorial. And what we've done is wipe the 52 factorial, the first 47 numbers out. 52 factorial, we would have the 52, the 51, pardon me, this is 47 factorial. So we'd wipe out everything from 1 to 47 in 52 factorial, and we'd be left with this. Now that's the definition I'm going to use for what I'm going to try to do. My next plan is I want to write a program to compute C n comma m. These people love to use n and m. That's their standard way to do it. For small n and m. I'm not taking big numbers. If I want to do big numbers, I have to find a little more cleverness, because it just, my machine can't handle it. So let's see, how would I do this? Well, I have a trick up my sleeve. I already have the factorial function. So I don't have to rewrite the factorial function. I can go and use it. So now I'm going to go back to here, and I'm going to make sure I copy this. And I'm going to close this program, if I can get it to close, because something's in the way up here. Yeah, I can move that. So File, Close Solution. And now I'm going to bring up another one, which I'm going to call com of n by m. And I'm going to replace this entire thing with what I just copied. So what I'm going to be doing here is, this is going to be the com of m by n. Now it says over here in my argument, in my working this out, that all that is a couple of factorials. So why don't I do it this way? I'm going to ask the user now for 2 things. Cout input N and M integers less than or equal to, let's say, 12, and we will compute C n comma M. By the way, never break your line inside these quotes. Never. That can get you all kinds of trouble. If you need something longer, put the quote in, go to the next line, and then just continue with the chevrons and the quote of the rest of it. But be very careful. If you do it the other way, you're on your own trying to figure out what it, no, it will be, we'll figure it out. You shouldn't. So there I am. Now, I'm going to say the combination of n things taken m at a time is, okay, I better go to a new line because I'm running out of room. Oh, come on. There, that gets me to a new line. So let's see what I can do. I can write the function combination, so why don't I write it? So com n comma m. So there's a new function I need to write. So I'm going to go down here and write a new function. It's an integer, int com int n. Again, I'm going to use different names, int x, int y. Or if you want, I want to put int top and int bot for bottom. So if it's n over m. Now, this is going to be nearly trivial because I have this formula right here. I'm going to just plain, more or less, copy it. So 52 was n, and 5 was m. So the formula is n factorial divided by m factorial times n minus m factorial. That's the whole formula. So what I write here is return factorial of n divided by, factorial of x, that's the top number, factorial top, that's the top number, bot, and I need this parentheses because I want these both in the denominator, times the fact of top minus bot. Close parentheses, close this. It's done. But of course I need the prototype, so I have to take this here and move it up here. And remember to put my semicolon in. Now, the machine is complaining. This is a good question. Take a look at it before I fix this. Why is the machine complaining there? I'll give you a minute or two to try to figure it out yourself. Why is that happening? Why is there a red line there? There must be something wrong. What is it? Well, there's something missing. Remember, you have to put these things in, and they have to be separated by chevrons. So that was the problem. All right, well, we better make sure we can solve one of these. We'll have a case to look at. So let's see. Let's suppose that what is C5 taken 3 at a time? Well, it's 5 factorial divided by 3 factorial times 5 minus 3 factorial, which equals the top 5 times 4. The 3 factorial wiped out the 1, 2, and 3. And then the 5 times 3 is 2. So I think I divide by 2. And there's an outside chance I have the right answer, but I wouldn't want to bet on it. So I can take 5, 4, 3. That's 5 times 4 is 20 times 3 is 60. And 3 factorial is 6. So I think that's correct. 10 is the correct answer. So let's see if we get that answer when we try 5 and 3. I really ought to have tried it first to see if I could get it and then fudge the correct answer. But I didn't do it. So we'll put in 5 and 3. And the machine came up with 0. Now, why in the world did it come up with 0? That doesn't make a bit of sense, does it? Why in the world did it come up with 0? So let's take a look. What's our question? Well, our question is, did we do everything the way we were supposed to? Well, n became top, and that's here. Oh, I see the problem. Do you see the problem? It's a typo. Right here. I wish I didn't make those. Now let's see if we got it now. 5 and 3 produces 10. So that's another example. And it's an example of a function using a function. So that's another one we can look at. Let's see, shift, control this, control V, and put this in. Okay, there we are. And I'll get rid of this up here, and I may be able to fit it on one page if I do that. Let's see. Yep, can do it. So far, we've figured out how to use functions. Now, I want to point out something here. This function, com, is written in terms of top and bottom. Those are the variable names in com. But whatever we pass, n, we pass the value of n into a secret variable called top, a variable that is inside the function com. There is no n inside com. The value of n has been copied into top. It's like a renaming, like a changing to a different language. Out here in the main line, we have n and m. but the people inside COM call them top and bottom. They're just copied in. N and M are meaningless inside here, inside COM. And furthermore, when I pass top into fact, top no longer it has a meaning. Its value has been copied into X. And when I put bot into fact, its value has been copied into X. And when I do this one, we first compute top minus bot, and then we copy the value into X. Now, it's important to realize that the variables that are the parameters are the names within the functions. When we use them, we copy the values from wherever we are calling the function into those variables. This will be important probably in the second video I make on this. This is the way that you're used to it if you're used to Python. But Python does not have the other way to do it that we're going to talk about very soon. Now, I think I'm going to end here. I think this is enough for now. So I'm going to close this. And as usual, I will send you the video and the handout. See you later.